No.
Going.
Thank you, lady.
All right, let me plug this bad boy in. So we're looking at number 30, you said?
Bluetooth mode.
Uh-oh. Give me a second.
Bluetooth connected.
All right. I think that's working, yes. Okay, so on this problem, it said, oh, these are these. I don't remember if we did any of these in class yet. Let me show you this. Hold on. So this one says, express these in this form. So it's kind of like, normally I give you a G and I give you an F, and then you plug G into F, right? So this is actually the opposite of that. It's saying, what would F and G be? So the result is this. That's what they're asking. You guys with me? No? Oh, wow. I'm like, darn it. All I did was this, tell you what the problem was. I haven't tried to explain anything yet. Now, maybe if I give you an example. So let's see an example. What if I had this? H of x equals, what do you got, Jeff? 6x plus 1 squared minus 7 over x plus 1 squared. Okay. So my job is to figure out what would F be and what would G be so that the result would be this. Can somebody tell, is there a function that seems as if it's an inside function? Is there a function that seems like it's inside something else? I mean,
X plus 1.
Yeah. In fact, yeah, that'll work, but it's, I'm going to even go with what I was thinking. I'm going to call G of x, x plus 1 squared. So what would F of x be? Well, if I plug G into F, and that means putting x plus 1 everywhere there's an x, that must mean there must have been an x here and here. So F of x would be no, Jeff. 6x minus 7 over x. So then if I do plug G into F, I would end up with this. No, there's a lot of drawing happening there. So this problem is much easier than that, right? But it's the exact same idea. Does that help at all? I mean, a problem like 26 is very simple. Can somebody tell me what part of 26 seems to be inside? What part of 26 seems to be inside?
X plus
Hopefully, yeah. Are you guys with me at all? I mean, this should be kind of you trust your gut. Doesn't it look like x plus 2 is inside and the square is on the outside? So if I wanted to define what this would be to make it become this, my inside function would be x plus 2, and my outside function would be x squared. So then if I plug this into this, don't I end up with this? That's the question. Can you figure out what's the inside function, that's G, and what's the outside function, that's F? Maybe? Let me know if that's not good enough. That's my whole job, is to explain. So is that okay? Faye? Yes. You sure? Okay. I'm going to accept that answer. Okay.
Yes, I get
Alright.
it. I was just having a hard time seeing how like pulling it apart. So, but now I get it. 'Cause you're saying it's like what's inside of like this.
Yeah, and sometimes the inside idea doesn't directly work, which is why I wanted to give you this example. But you can just say, what could I replace with X? And then G would be what I just replaced with X. So it would go in. I don't know if that, I might have just made it worse right there, but oh well. Okay, guys, anything else? Any other questions? You guys doing all right? You guys doing all right? It's the end of the second week. We are so ready for a 4-day weekend, right? That's what we got coming up. I don't know, unless you guys have Friday. I have a 4-day weekend because I don't have any Friday classes. But Monday's a holiday, remember? Nicole's going to party. I saw that reaction.
So g of x would then be the cube root of x.
Well, yeah, if you want to give the answer away, Austin. Yes, you're right. You're right. But be quiet. Don't say it again. Keep it to yourself. Now do the problem. Okay. Something like number 31 would be very easy then, I would hope, if you understand what I'm trying to say. On number 31, what would the inside function be? What is obviously the inside function? If I look at number 31, do you agree with me that there is something inside something else? What is that thing that's inside something else?
Is it a fraction?
Yeah. So
It's
what?
gonna be 1 over 2x minus 3.
Yeah. And then what is that inside of? The cube root. So if I put g into f, it becomes what they gave me. That's the whole point of the problem is, can you figure out what the g function is that gets put into the f function to become what they give you, right? So it's just the idea of composition backwards. I mean, so the thought process is if you could do it forward and backwards, then you could do it. You could do it really good. Okay. All right. So I'm going to clear all that away. Here it goes. It is gone. Okay. Anything else, guys? Anything else from homework? Hopefully, I do have a couple of chapter 3s turned in, section 3s, I mean. And I will get caught up this weekend with grading. Obviously, I've been grading a bunch of quizzes. I gave another quiz, so I've been grading that one for a different class. Anyway, so my focus has not been on homework here for a few days. Everybody else okay? No other questions from homework? You're all okay. All right. Okay. All right. I'm an optimistic fool, so I will take that as a good sign. Here, let me make this all about me real quick. There we go. That's better. By the way, I might as well say something about this. I don't know if you guys can tell. Can you guys? I don't know which way I'm supposed to, I could look. I don't remember which side it's on. Can you guys see one of my eyeballs is a little bloody? Do you guys see that?
Right side.
Yeah. So 2 years ago, I was driving back from Temecula. I had gone up to Temecula, met some friends at a Cuban restaurant, and then I was driving back home. And all of a sudden, I couldn't see out of this eye. I couldn't see out of the eye. So I went to the ER. Come to find out, I've got like a genetic predisposition for this thing to happen. So now there's a 5% chance this eye is just going to go away, and that's exciting to live every day like that. But I've got to go every 7 weeks, and some of you guys are not going to like this. I got to get a shot in my eye every 7 weeks. Yay! Just to give it a chance to heal, so I can see a lot more. But it's sort of like trying to look through your shirt. Have you ever done that? Sort of trying to look through a thick shirt. But anyway, so why do you have to know that? Just because in another 7 weeks, I think on April Fool's Day, it's going to be all bloody again. Just so you know, I'm not like getting into a ton of fights or anything, right? I'm sorry, Nicole. That's all I'll say about that. Back when it first happened, I had to tell my class because they would come to turn papers into me and I had no depth perception. So I was trying to grab their paper and I'm like, oh crap. And now my other eye's taken over. So I have all my depth perception back.
So are you just
I'm even able
blind
to
out of
play
that eye
basketball.
for like a while?
Say again, sorry.
Are you just like blind out of that eye for a while?
No, I can see fine. I mean, I can see as good as normal, which is not good. I'm never going to get the sight fully back in this eye ever. So that's exciting. And like I said, this one might go out any second.
And it only bleeds when they shoot it, or does it bleed on its own?
Oh yeah, this is from the shot. So
Okay, cool.
it'll go away. One time it was completely red and I forgot about it and I went to a store somewhere And the person behind the counter was like, I was like, oh yeah, I forgot about
You should
Thank
totally
you.
just go get your next DMV photo, like right after your
There you
shot.
Should have when they said Sarah Connor. So I don't know if you guys get it. All right. Anything else from homework? Let's just get away from my eyeball. I just want you guys to know, in case you saw it was bloody, you know what's going on. Okay. All right. So I want to do a couple of things with the last thing we talked about. Inverse functions. I want to really highlight something that we didn't really hit on last time. I think I might have said a little something about this, but I saw a really good example I want to do with you guys. It was right there. Okay, perfect. All right, here. Can you guys take a minute? Well, dadgummit. Take a minute and find that guy's, oh shit, sorry. Find this guy's inverse. Can you see that? Find the inverse for this function. Let's see if you guys remember it was like an entire day ago. I know. So let's see if you guys remember what we did way back then. Remember those times yesterday? Oh, we were so carefree. All right. Put it up here. And real quick, how do you know this has an inverse? What would this look like?
A 1-to-1.
Yeah, why is it 1-to-1? What's the shape of it? I know it's hard to say it. I don't know. You could draw it in the air if I could see you. Excuse me. I need some liquid. So it looks like a square root function, right? Square root function looks like this. Oh, here's a little review. All right, let's do some extra work here. What would the shifts be? What would this shift be?
Right.
4 to the right.
4 to the right. And then what would this shift be?
2 up.
2 up. I like it. So it starts up there and it goes like that. So what is this guy's, here, real quick. What is this guy's domain? You can see it from the graph that we made now.
4 to infinity.
4 to infinity. I love it. And somebody else tell me what the range is.
0.
Now look at where it is.
2 to infinity.
2 to infinity. Are you guys all right? You guys see that? That's kind of nice. If I graph it, I could just see what the domain and range are. All right, now watch. Now you guys working on this? So, oh, I got it way up here. Bring y back, keep going. Go ahead and find this guy's inverse. We know one exists because it is 1-to-1, check. I want to show you something neat. And just to remind you guys, you don't have to, but if anybody else is able to turn their camera on, that would be much appreciated. But if you cannot, I understand. I've got mine on and I'm all blood-eyed Jeff. Thanks, guys. I appreciate that. That helps me retain like a little tiny bit of sanity. All right. So let me catch up here. You want to switch the X and Y. Then you would subtract 2, right? And then I would do what?
Square both sides.
Square both sides. I love it. And then the last thing, let me see if I can save some time. I would add 4, right? So I get y equals x minus 2 squared plus 4. And I think I told you guys, please don't worry too much about, doing anything to a power. You can just leave it like this. Now, can somebody tell me, do you guys see a problem with this? Is this function 1-to-1? Is this function 1-to-1?
Yes.
Try again. What's it look like?
Isn't it parabola?
I'm sorry? Oh, parabola. Yes, it's a parabola. It's been moved over to up 4 parabola. Is that 1-to-1?
No.
No.
No, it's horizontal line test fails. So have we done something wrong? No. But here's what I really want you guys to get right now. Get ready. Can somebody, let me see if you guys can do this. We did this graphically. We do this algebraically. What's the main point of inverse functions? How do I create an inverse function? What's the main thing I always do? We did it graphically. We did it just now algebraically. What is it that we did? You could do it.
You switch the input and the output?
Exactly. And you said it perfectly. So what happens to the domain and range? Wouldn't they just switch? Because all my X's and Y's switch. All right, good. So now watch what this does. All right, I've really put this together poorly, but that's too bad. So let me put over here. Here is what we got as a result. We got, are you guys cool with this? Because it would be over to up 4, right? So it'd be a parabola right there. And that is wrong. It's supposed to have a domain of this guy's range and a range of this guy's domain. Because what do inverse functions do? They switch the X and Y. So they switch the domain and range. And this is exactly what we talked about yesterday. If my domain is supposed to be 2 to infinity, don't I chop off this half of my parabola? Parabola? Die. Okay. And then it does become 1-to-1, right? It does become this shape. See this shape right here? If I were to flip it around the y equals x line, it would become this, wouldn't it? It would become wee-ha. So everything comes together beautifully. That's going to become huge later this semester when we talk about trig functions, trigonometry. This idea of inverse functions switching the domain and range. It makes so much sense because everything we do with it, graphically, we switch the X and Y. Algebraically, we switch the X and Y. So domain and range switch. Of course they do. All right, maybe, Jeff. Okay, all right. Now here's something else that's neat. So that's number 1. That's always true. When is that true, Jeff? Always. That's how inverse functions relate to each other. So it's always true. So I'm going to clear all this away. It's going away. Bye, stuff. Okay. Now, here's another problem for you guys to try. Nobody say anything. Find the inverse of that function, please. Why do I have that song in my brain? All right. This should be pretty quick, hopefully, right? If you switch the X and Y, what's the first step I have to do to start solving for Y?
Multiply both sides by y.
Yes, I mean, the thing I'm trying to solve for is in the denominator. That really sucks. So obviously the first thing I want to do is free that dude up. You multiply both sides by y. And then of course I just have to divide by x. So what do you notice? The inverse of 1 over x is itself. The only thing we have to know. Shut up. So why does that make sense? Remember, every inverse function, visually, how does it relate to the original function? Do you guys remember? Where's the mirror that I put down?
It's directly between the y and x.
Yes, y equals x. So any function that is already symmetric, I really want you guys to get this. Any function that is already symmetric to that line, when I flip it, it's the same function. So guess what this looks like? Do any of you know what this looks like? It's actually one of the functions you should know how it looks. Does anyone know?
It's like two opposing curves.
Yes, so this looks like this. See how it's already symmetric? Oh crap, especially if I could draw it right. It's already symmetric with respect to that y equals x line. So when I flip it, it's the same thing. And think about it even more, even better. How do I, so what does that function do to an input? If I put a 3 in, what happens to the 3? It becomes what? If I put a 3 in to this, what does it become? If I put a 3 in.
1/3.
1/3. It flips it, doesn't it? So what's the opposite? How do you undo a flip? Don't you flip it again? Doesn't that make sense? So of course, how do you invert a flip? Flip it back. So of course it's its own inverse. Okay, maybe. Are there other functions that are their own inverse? What do you guys think? Isn't this neat? Anybody find this neat at all? Okay, somebody does. Thank you, David. You even said that before I asked, so I might even believe you. What do you guys think? There's a really easy function that's its own inverse. What is already symmetric to y equals x?
Y equals x.
Y equals x. And of course, that's its own inverse because that doesn't change anything. How do you undo not doing anything? You continue to not do anything. All right, good job. So of course, y equals x is its own inverse. How about another one? Anybody have another function that would be its own inverse?
Will you always be finding y, or can you be finding x too?
So, all right, the thing we're focusing on now, because I know the book does it a little bit differently. They switch the x and y at the end.
Yeah.
There are multiple reasons to solve a function for a different letter. In this specific context, we will always be trying to get y by itself again. Or like the book does it, it just switches the y at the end, right?
Yeah.
But there are other things, other reasons to solve things for the other variable. So that's a more general idea. Here's a really cool one. All right, let's see if you guys can handle this. We did one like this before. Let me give you a function. I just want to be lazy today. I don't want to go up on my whiteboard. I don't want to turn off my Death Star. Let me see. I made this earlier. Yeah. I know an infinite number of functions that will work. And of course I do. I freaking know math. So what the shit? Why wouldn't I? Can you guys find this guy's inverse, please? I'll wait. Find the inverse of this dude. And then I'll tell you the secret so that you know an infinite number of functions that are their own inverses. Oh. right, Jeff, stop. Sorry. I don't know if you guys remember, there was a problem like this. I think it was in one of the reviews. People hate this problem. I don't get it. This poor little problem. All right, so what would you guys do first? There was a problem we just did that tells you what to do first.
Multiply both sides by denominator.
Yeah, so you can free this guy up. So then you get 2yx minus x equals, bam, bam, y plus 1. I'm trying to solve for y. You've already learned in algebra how to do this shit. You get everything with the variable in it on one side. So let me add x, because that doesn't have a y in it, and I'm going to subtract y. So get 2yx minus y equals x plus 1. So these just change places. Right? I want everything with a y in it on one side and everything without the y in it on the other side. Isn't that what you learned in algebra? One of the most basic things about solving equations. And this is what some of you guys just kind of forget. All right, let me ask you, how many y's are in this equation?
0.
What? Sorry?
3.
I like that one. That was unexpected. There's one y. There's one y. Because I can take that y out. Look, see, there's one y. Right? I just took it out. It's a GCF. And then what's the last step to get y by itself?
Divide.
So I get the inverse is x plus 1 over 2x minus 1, which is the same thing as the original. What the shit? So watch this. If you give me a function that looks like this, ax plus b over cx minus a. Do you see how that's what this is? A is 1. So this is minus a. B is 1 and C is 2. So you give me any function that looks like this, it will be its own inverse. Anyway, all right. The funny thing is, have any of you ever heard of the idea of matrices? Matrices, using showing equations in the form of a matrix, and I don't mean there is no spoon, right? Matrices. Some of you guys, I saw somebody saying yes. This idea will show up again then, which will be very interesting. But we'll have to wait till then. So I'll remind you guys. Okay, so that was a couple of weird things about inverse functions. Was number one, the domain and range flip, which makes sense because we switched the x and y's. So of course they do. And number two, there are some functions that, in fact, there's an infinite number of functions, but that are their own inverse. Kind of freaky. Kind of freaky. All right, I'm going to clear all this away. It's going away. Bye, stuff. Okay. Now, just to show you, the next chapter is, it has to be simple. This is kind of crazy that they gave this own chapter in pre-calculus, but everybody needs to be comfortable with this for damn sure, right? I like it. But let me ask you this kind of question. Let me see. Do I have some white space here? Yeah. Forget about this graph. What if I had a plumber, and he charges $80 to come to the house, plus $35 an hour. Can you represent that with a function, what the price would be at some given time X? So X hours equals what cost? Can you create a cost function for me?
Y equals 35x plus 80.
Yeah, so the cost, this is obviously going to be the slope because it's per hour. So that's the part that's changing, and this is the fixed part. That's fixed. So, I mean, that's the one piece, and that's sort of on the edge of a word problem, right? And students, no matter how easy or hard they are, I notice that students sort of shut down when they realize it's a word problem. You're like, I don't know those, they suck. That was not hard, right? And that's basically a very basic type of word problem. Because now I could say, I had to pay him $40, $400 bucks. How long was he there? And you have to put 400 in and solve for X and blah, 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 right? So this is just one example of modeling with linear functions. Linear function modeling, right? Okay. No catwalks, just modeling the real world with math. Okay. I don't know. There might be catwalks somewhere. I don't know. Okay. And let me see. What was the other weird thing in here? I'm going to clear all this away. It's going away. Bam. I think there was something else I wanted to show you here. No. Yeah, this has got to be easy. Give me a break. Here we go. Well, this isn't weird, but this isn't it either. So this is slope is a rate of change. When you first learn slope, they really hopefully taught you that in the first place, right? That's why the $35 per hour was the slope, because that's the rate of change of cost over time. Have you guys seen these symbols before? The little triangle dudes? I think
They came up in chemistry today.
Oh, cool. Perfect.
Yeah.
And we saw it in the calculator when we looked at the table setting. Somebody pointed out what that was.
There's a delta.
Delta. And it means, what's it mean, David? In chemistry.
I wrote it down somewhere.
That's all right, man. I'll put you on the spot. Don't worry. I don't control your chemistry grade, so you're fine. So that means change in. So I'm really curious which part of chemistry it was talking about, but normally that's change in, like delta T would be change in temperature, maybe capital T. Anyway, so if you've never seen those symbols before, don't worry. It's not going to show up like a ton. Blah, 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 blah. So stuff like this, you should be able to eat this stuff up. Oh my God. If I ask you to find the slope between 2 points and you have problems, that is a problem. That is an issue. You should be able to eat this stuff up, right? Okay, hopefully. There was that question about the perpendicular line on the quiz, I think, right? Do you guys remember that? So parallel lines have what kind of slopes? How do the slopes compare for parallel lines?
The same.
Exactly the same. Perpendicular has
The inverse.
Totally opposite, not just inverse, negative inverse. So if one slope is 1/2, the other one is -2. Okay, maybe. All right. And what's the other equation for a line? That we got the y equals mx plus b. That was up there. What's the other one? Anybody know?
Is it the point slope formula?
Yeah. Nobody's going to help me. Okay.
Yeah. M times x minus x1.
which is just this formula. Get out of there. It's simply this formula. Multiply the x's up and take the 2's off. That's all that formula is. It's saying the slope is the same no matter what point you pick on the line. That is basically where that equation comes from. If somebody gives me 1 point, does it matter what other point I pick? No. It could be any other point and the slope is the same. That's the idea of a line, straight line. All right, I love you guys. Here we go. Clearing this out. Uh-oh, here comes a chat. There you go. Yeah, because chemistry, you're probably going to do a lot of graphing in chemistry of different things over time, taking temperatures and stuff. Let's see. Yep. Okay. So let me clear this. Blah, 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 blah. All right. I mean, this section really, you should, like I said, I almost want to be able to say, if you have a lot of trouble with this section, you should feel bad. I'm sorry. It's true. This should be really, you should be, oh, thank God that this section exists. I'm trying to remember if there's anything weird in here. I don't think so. Somebody cool with like, how would you, no, this is dumb. How would you graph this without plotting points? I mean, right, can everybody just take a minute and graph this only using what they tell you? Don't do any other work, just immediately graph it.
Isn't
Oh, wait, don't say anything.
okay.
Sorry, unless you have a question, don't say anything. I might be giving something away how I'm putting this together, but oh well. My scale sucks bad. Oh well, too bad. Yeah, I can't handle it. I can't do it. My scale. Oh wait, I can do this. I keep forgetting I have this ability. Look at that. That helps out a little bit. Jeez. All right, fine, Jeff, whatever. All right, so somebody help me out. I'm sorry, I cut you off. Where do you start on this line?
Is 6 the y-intercept?
Almost. And I love it. Right now, you're like, what the hell's wrong with this guy? All right, let me be a real asshole. The y-intercept is 0, 6, right? It's got to be a point.
Right.
So that explains to some of you guys why that problem in the review, when you said the y-intercept was like x equals 1/2 or something, and I'm like, no, or whatever I did, it's a point. You got to put a point. And you're like, all right, whatever, math boy, but it's a point. So 0, 6, and then how do I move from there?
Up 3, left 4.
You could go up 3, left 4. I don't want to because I didn't put anything up here. So I'm going to, instead of going up 3, left 4, I'm going to go down 3. 1, 2, 3, and right 4. 1, 2, 3, 4. So I'm going to be right there. I think, yes. 1, 2, 3. 1, 2, 3, 4. Yeah, okay. Chumbawamba. Because of course, if I go up 3 and back 4, I'm still on the line, right? That's amazing. So the slope could either be seen as -3/4, or it could be seen as 3/-4. Math says it's the same dumb number. Slope says they say kind of two different things. All right. This should not be ground shaking stuff, right? This is kind of nice. All right, I'm going to clear all this away. Clear it away. Bye. Okay. Let me see. Was there anything else weird? No. Yeah, this is an interesting question. I like this question. Is there a line? So let me ask a different question than this. Is there a line that does not have a y-intercept?
Yeah,
What would be true about that line?
it's parallel to the y-intercept.
You almost had it. It's parallel to the y.
Axis, sorry.
Okay, okay. I love it. I was like so excited. I'm like, that's perfect, perfect. Oh, okay. I know what you meant. Because if it's a vertical line that is off from the y-axis, then it obviously will not have a y-intercept. But is this a function? Is this a function?
Super not.
Super not. That's exactly the technical answer. That is the worst way to fail the vertical line test, is to be a vertical line. Because the vertical line test is like, all right, let's see. Oh shit, oh shit, oh shit. Everything on you intersects me. So it's like it fails the worst. But do all linear functions have a y-intercept? Hell yes. Because the only line that does not have a y-intercept is itself not a function. I love it. Okay, okay, maybe. So I'm trying to get a little bit deep here with this stuff, but it's hard to get deep with lines. All right, let me clear this away. Clear. Oh, let's see. Blarf, blarf. Okay, okay. You should be able to do all this stuff. Yeah, that's what we just did up here. Y-intercept and slope. You should be able to do that. Okay, blah, blah, blah. Blah, blah, blah. I don't care about all this crap. All right. That's dumb. That's dumb. I don't care about transformations with lines. It's not very interesting. Okay. Yeah, that's enough for that. So to be honest, I really don't want to have a long class tonight. I'm sure you guys are okay with it. So I'm gonna end class now. We're in a good spot. So just over the weekend, I'm gonna catch up with grading homework. So over the weekend, you guys need to catch up with doing homework in chapter 3. If you turn that in sometime over the next couple days, I should have it graded before Tuesday. Monday's a holiday, remember? We have Monday off. Yay. And I'll update the Zoom link for the lectures next week. I'll put the update up in Canvas. Okay. So let me know if you need to hang out. Otherwise, you are free to go. Yes. Enjoy.
Thank you. Have a good one.
Thanks,
Thank you.
Professor. Have a good night.
Thank
You
you.
too.
Have a good weekend and holiday.
Oh, heck yeah. You do the same thing. My eye will feel better a couple days. Tonight's the first night's always the roughest, but it'll be better tomorrow. You guys all right? Everybody okay? I'm gonna head out if I don't see any questions.
I have a question about from
Yes.
the quiz.
Yes.
Question. It was 1C.
All right, hold on. Let me look you up here.
Actually, I have a couple of questions. So.
All right, 1C. Oh. Wait a minute. What was my problem? Did I just misread what you put? Let me see what happened here. That's kind of weird, Jeff. 49 minus 3 is 46, and that's exactly what you wrote down. I have a feeling I just misread what you wrote. Although the real problem is I'm still going to keep the -1 because I think the real problem is the top. You never distributed the top, so you didn't really simplify it.
Yeah, I redid it last night and I figured out the top, but I just couldn't figure out the bottom because
The bottom is fine. I wish I could say I meant to strike through the top, but no, I think I just misread your bottom there. So I don't know what I was thinking. But yeah, so show me the distribution on the top and that's good. Otherwise, the bottom's fine.
Okay, and then the other one was number 2 for 2B, and for the graph, like
Yeah,
graph,
so you thought that I meant to graph the absolute value. No, I said graph the solution, not the problem.
yeah,
Right? So you just
yeah,
need a number line. I think you've got that in there. Let me see. But you had issues with your.
I just for some reason thought, like I was thinking absolute value, and so I graphed it, and then when I tried doing that, I was like, something seems wrong.
Yes, but do you see what you did wrong with the intervals? The problem should be a sandwich, but you had something where it's like
Yeah.
out. You had them up the wrong way around.
And then when I shaded it in, I was like, well, that doesn't make sense because it should be in the middle. So
Yes, yes. Because see how yours, you have greater than 2/3 in your interval, but the answer should be less than 2/3. And you have less than -2 when it should be greater than -2. So greater than -2, less than 2/3, sandwich.
yes. Okay, cool. And I think that's, yeah, I think my last one was just number 4, but I think I figured
Yeah,
it
we
out.
just, yeah, now you know, you got to switch that slope. That's what went wrong.
All right,
Negative, yeah.
perfect. Okay, that's it. Thank you. Have a good
Okay.
weekend.
You too. How's everybody else? You guys okay? Are you guys actually there? I know Charles is. I see him. All right. I'm gonna head out if you guys don't have any questions. I'll see y'all next week.